Hello everyone, welcome to this video. In this video we shall see question from December 2012 consisting of 4.75 marks. The question says, given the initial value problem d2y by dx square plus y is equal to 0, where x is greater than 0 and y at the point 0 is given to be 1 and y dash at the point 0 is given to be 1. That means we are given the initial value problem and they are asking this initial value problem is equivalent to the Volterra integral equation which among which of these four, right? So this initial value problem is equivalent to A, B, C or D, which one of these? So although it involves differential equation, but we can solve it using the methods of integral equation. The thing that you need to know is to convert any integral equation to the given differential equation, we must differentiate it, and the rule for doing this is Lebanese rule. What is that? It is taking the derivative with respect to x of some function under the integral sign, where the limits of integration are some function of ax and bx. It could either be constants, right? So depending on the question, these could vary. So it would be equal to integration from ax to bx, the partial derivative of the function ux with respect to x, right, plus the complete derivative of this upper limit bx, and this function where this t is being replaced with the upper limit bx, like this, minus the derivative of lower limit, and this multiplied by this function where again this t is being replaced with the lower limit, that is ax. So this is the rule. So let us get started. Let us see by each options, right? So we'll take the first option. This is given to us, the integral equation. We'll differentiate it twice and we'll see what is the whether the given differential equation is equivalent to the one that we have obtained. So for the first option we have yx is equal to 1 plus integration from 0 to x t minus x yt dt. So if you differentiate it once, you'll get y dash x with respect to x, right? So it would be y dash x is equal to integration from the integration of 1 would be 0 plus the integration from 0 to x, the partial derivative of this thing with respect to x. So t would be constant, so it would be 0 minus 1 into yt dt, so this term, plus the derivative of upper limit is x, so its derivative would be 1, and next we have this whole function where t is replaced by the upper limit, that is x. So x minus x into y of x minus the derivative of lower limit, that would be simply 0. So the term here would be meaningless. 0 into something would be simply 0. So it would be this term also becomes 0, right? X minus x. So we are only left with this thing. So now we can again take the derivative. So it would become y double dash x. And here again we have to apply this Lebanese rule. So it would be integration from 0 to x, the derivative of this thing with respect to x. Now see, there is no x, so its derivative would simply be 0. So this term, initial term, would be 0 plus the derivative of upper limit with respect to x, that would be 1, multiplied by the whole thing where t is being replaced by x, so this thing, and minus the lower limit, derivative of lower limit, that would be 0. So this, only this thing, so that becomes y double dash x plus y of x is equal to 0. And so can we have a look that this is similar to this one, exactly equal in fact, and we can also check the limits. Y at 0 is equal to 1. So if we substitute 0 over here in this equation, so this becomes y of 0. This is equal to 1 plus integration from 0 to 0 something. So integration from 0 to 0 would result in 0 only. So y of 0 would be 1 and y dash of 0 would be 0. So y dash is this one, right? So if you put 0 in place of x, so it would be y dash of 0 is equal to integration from 0 to 0. So that would simply be 0, right? So y dash 0 is equal to 0. So this is the correct option. So we got one correct option, but because this is a multiple choice question, so we have to check for other options also. So let's do it quickly. For second option, we are given y of x as this. So we can differentiate it once. We'll get y dash x is equal to the derivative of 1 would be 0. Integration from 0 to x. The derivative partially with respect to x would only give yt dt, because it would be 0 plus 1, right? So yt dt plus the derivative of upper limit, that is 1, and placing x in place of t would be x plus x into y of x minus the derivative of lower limit, that would be 0. Right, so we would have y dash x is equal to integration from 0 to x yt dt plus 2x times y of x. So now we can differentiate it again. We'll get y double dash x is equal to, now again we have to apply the Lebanese rule. So here the first term would be 0 because there is no term containing x. The second term would be only y of x, because the derivative of x with respect to x is 1, and the third term would be 0, and then its derivative with respect to x. Now we have two terms containing x, so we can apply the product rule over here. So firstly I'll take the derivative of y dash x, so 2x as it is, y dash x plus 2 into derivative of x would be 1 into yx as such, right? So the second derivative would simply be y double dash x is equal to, we can add up these two, so it'll be 3y of x and 2x y dash x. Now this does not match with the one given in our question, therefore this option is discarded. So this is not the correct option. So option B is not the correct option. Let us look at third and fourth. Option third is, we can differentiate this, right, in the similar way. Now again we can differentiate it. So you will get something like this, because this term is independent of x, right? So it would result in 0 plus when you substitute the upper limit, it would be like this, lower limit with 0. Here you have to apply the product rule of differentiation, that would be 2x, derivative of x square 2x, yx as such, and x square as such, derivative of yx would be y dash x. So it will be something like this. Again, this does not matches with the given form, right? So because the given form is this, so this option is also discarded. So let us look at the last option, D part. So it is given to be y of x is equal to 1 plus integration from 0 to x, x minus t, yt dt. So we can differentiate it once. Y dash x is equal to integration from 0 to x, yt dt plus x minus x yx is equal to 0. And again taking the derivative, we'll have something like this, right? Now this is also not the correct option. Why? Because in our question we are given y double dash x plus y of x is equal to 0. So this also does not match with the given initial value differential equation. Therefore this is also not the correct option. So the only correct option is option A. That is it for this video.